Today we are going to complete the variables and equations notes. This is the introduction lesson into solving equations, which we will spend the next several months doing. The target for this lesson is that you will be able to create equations using mathematical vocabulary. So let's go over a few vocabulary terms that you should be familiar with for today's lesson. The first word is equation. An equation is a mathematical sentence that is formed by placing an equal sign, which looks like this, between two expressions. Everything we have done so far has been expressions. Now we're going to work with equations because they're going to have equal signs setting two expressions together. And the goal is to find the solution of the equation. The solution is a number that produces a true statement when it is substituted for the variable. So for example, if I had the equation x plus 2 was equal to 5, I'm looking for the value that I can plug in for the number x that will make this equation true. And for this equation, there's only one number that would make the situation true, and that number would be 3. Because if I substitute in a 3 for x, 3 plus 2 would be equal to 5. So when we're solving equations, the goal is going to be finding all the solutions of an equation. On this slide, you'll see some clue words that'll be useful in today's lesson. There are some words that indicate whether we should be adding, subtracting, multiplying, or dividing. There's also some keywords that indicate when an answer is involved or an equal sign, a few keywords when the order needs to be reversed, and just some notes about multiplying and dividing over at the bottom. This is a great slide that for you to print out and reference in the future. All right, example number 1, writing verbal sentences as equations. So on your paper, when you're taking notes, copy problems A through D down. And then together, we are going to turn those into equations. Problem A says the sum of x and 4 is 8. The key word here is sum, so I'm going to underline it. If I go back and I reference that clue sheet that we had on the last slide, sum is one of those words that indicates addition. And I'm adding together two things. I'm adding together the x and the 4. So my equation will literally say x plus 4. Then the last part of the sentence said is 8. Is one of those keywords that indicates an equal sign. So equals 8. So my equation just says x plus 4 equals 8. Problem B, the difference of 7 and y is 23. In this problem, the keyword here is difference. And difference tells me that I need to use subtraction. So again, I follow the order. I need to do the difference of 7 and y. So that's just 7 minus y. This end part here says is 13. Again, is a word that represents equals, so I just write equals 13. Problem C. This says the product of negative 2 and p is 24. Product is another key word, and product tells me I should be using multiplication. I'm multiplying negative 2 times p. Now, when you write your equation, do not use x to represent multiplication, because now we're getting into algebra, and x is going to be a variable. I don't want to get confused whether x is representing multiplication or whether it's representing a variable. So instead, you can just say negative 2p. If there's nothing in between a coefficient and its variable, it's implied that multiplication is going on. So negative 2p really means negative 2 times p. Then I have this last part that says is 24. Again, that just means equals 24. You could also write this equation as negative 2 times p using a dot. equals 24. So we're okay with the dot. We're okay if you just drop it all together, but do not use an X. Finally, problem D. Problem D says the quotient of n and 3. Quotient is another keyword, and that means division. So I'm dividing n and 3. So I'm going to write n over 3, because that means n divided by 3. And then I have is 5. That just means equals 5. So that's how I turn verbal sentences into mathematical equations. Time for a few you try problems. So the directions say, write the verbal sentences as an equation. Problem number 1 says the sum of x and 7 is 12. The key word here is sum. Sum tells me I should use what operation? Addition. So what would this equation look like? X plus 7 equals 12. Problem number 2. The quotient of n and 4 is 16. The key word here is quotient. Quotient indicates which operation? Division. So how would I write this as an equation? N over 4 equals 16. Okay, now that we've mastered how to write verbal sentences as equations, we're going to move on to example 2. And example 2 is all about checking possible solutions. So the directions here say to tell whether 7 or 8 is a solution of x minus 3 equals 5. So they're giving us 2 possible solutions. It might be 7, it might be 8. And we need to test each of those to see whether or not each one of those is a solution. So let's test the number 7. So for part A, we're going to substitute in 7 for x. So the original equation was x minus 3 equals 5. I'm going to take out this x, and I'm going to replace it with the 7, because that's what the directions told me to do. They said try 7, test it and see if it works. So we're going to check it. 7 minus 3 makes 4, and 4 is not equal to 5. It didn't work. In order for it to be a solution, I should get something that's true, and 4 does not equal 5. So therefore 7 is not a solution. You need to write this entire statement as your final answer. Do not just say yes or no, and do not leave it as 4 does not equal 5. The answer is that 7 is not a solution. Let's finish the problem. Part B. This time they want us to substitute in 8 for x. So we have a brand new number that we're going to try using the same equation. So again, the equation was x minus 3 equals 5. We're going to take out this x, and we're going to replace it with an 8. So now let's check. 8 minus 3 gives me 5. And in fact, 5 does equal 5. That's a true statement. So because that works, that means 8 is a solution. Again, that little statement there, 8 is a solution, is your final answer. All right, one more you try problem for you to try. Problem number 3. So they want us to tell whether 8 or 10 is a solution of the equation x minus 4 is equal to 6. So we have 2 potential solutions. We need to check each one. So first we're going to check to see if x is equal to 8. So using the equation x minus 4 equals 6, I'm going to take out the x and replace it with 8. 8 minus 4, is that equal to 6? Let's simplify the left-hand side. What is 8 minus 4? 4. Is 4 equal to 6? No. So because 4 does not equal 6, that means 8 is not a solution. So that's half the problem. Now we need to check the other solution of 10. So this time we are going to check if x is equal to 10. So using that same equation, x minus 4 equals 6, I'm going to take out the x and substitute it with 10. So now my equation says 10 minus 4. Does that equal 6? Let's simplify. What is 10 minus 4? 6. Is 6 equal to 6? Yes. So therefore, 10 is a solution.